By 200 years ago, I wasn't around then, chemists had accepted that everything was indeed made of tiny indivisible particles called atoms. But now we know that they are not quite indivisible. In the last 120 years or so, we have learned a great deal about the particles inside atoms, thanks to physics. First, the electrons. In 1897, the English physicist John Thomson was investigating cathode rays. These mysterious rays gloomed inside an empty glass tube when it was plugged into an electric circuit. He deduced that these rays were streams of charged particles much smaller than atoms. In fact, they were bits from atoms. He called them corpuscles, but soon the name got changed to electrons. It was a shock to find that atoms were not the smallest particles after all. Thomson imagined that electrons were stuck on the atom like raisins on a bomb. The rest of the atom, the bomb, had a positive charge. A year earlier, a French physicist called Becquerel had been working with the crystals of uranium salt. He found that they gloomed in the dark. By accident, he left some in the drawer, wrapped in a thick paper on the top of a photographic plate. To his surprise, he found an image of the crystals on the plate. They had given out rays of some kind that could pass through paper. He had discovered radioactivity. Later, the English physicist Ernest Rutherford found that the radiation could be separated into alpha particles, beta particles, and gamma rays. Alpha particles were found to be 7,000 times heavier than electrons with a positive charge. You could speed them up and shoot them like tiny bullets. We know now that they consist of 2 protons and 2 neutrons. Okay, let's move on. Marie Curie heard about Becquerel's discovery. She began to look for other radioactive substances and discovered the element polonium and radium. Marie Curie spent years searching for ways to use radiation in medicine. Sadly, she herself died from cancer caused by exposure to radium, but she was the first woman to win Nobel Prize. In 1911, Ernest Rutherford was experimenting with some alpha particles. He shot a stream of them at some gold foil. Most went right through it, but some bounced back. Rutherford deduced that an atom is almost empty space which the alpha particles can pass through, but there is something small and dense at the center of atom, and if an alpha particle hits this, it will bounce back. He had discovered the neutrons. He assumed it was made up of particles of positive charge and called them protons. So now, what about the electron shells? A question may arise here. If the nucleus is positive, why don't the negative electrons rush straight into it? In 1913, Niels Bohr came up with the theory of electron shells. This theory says that the electrons are not attracted in the center of nucleus because they are at constant movement in the orbit. It fitted all the experiment. Now, neutrons. In 1930, 2 German physicists, Both and Becquerel, shot alpha particles at beryllium and knocked a stream of new particles from it. In 1932, the English physicist James Chadwick found that these particles had the same mass as protons but no charge. He named them neutrons. So finally, 129 years after Dalton proposed the atom, the chemist's model of it was complete, the whole truth. But now for the whole truth, the model of atom that we use works well for chemists. It explains how the elements behave, but it's only a model, a simplified picture. In fact, atoms are far more complex than our model suggests. Physics have discovered around 50 different elementary particles within atoms. They include the up, the anti-up, the charm, the anti-charm, and the strange and the anti-strange. There may be even more to discover. So these tiny atoms, far too small to see, are each a troubling universe of particles, and we are made up of atoms. Think about that. Thank you for watching. If you enjoyed the video, give a like and don't forget to subscribe for more. Take care. Stay safe.